In this video, I will discuss JEE Main PYQ from the topic straight line motion. This question is based on graphs. First, let me discuss some basics. The equations of motion for 1D motion are V equal to U plus ET, and second equation of motion is S equal to UT plus half E T square. The third equation of motion is V square equal to U square plus 2AS. U is the initial velocity, A is the acceleration, T is the time, V is velocity at any time. This is the displacement at any time. So in this, if you put T equal to 0, the velocity is U. So here, if you put the initial time T equal to 0, the displacement is 0. And here, if you put the initial displacement as 0, then the velocity is equal to U. So these equations of motion, are they valid in all instances, or should we need to do some modification? So let me take a simple example. So there is a straight road and there is a car. Starting from this location at T equal to 0, and it's going to move towards right. Let this be the origin of the displacement axis. This is the origin. And let the distance of the initial position of the car be $50 meters. So in this second equation of motion, if we put T equal to 0, I'll get S as 0. But according to this situation, S should come out as 50 meters. So this equation should be modified as, instead of S, we should have S minus S naught. The S naught is the initial displacement. So this 50 meters is the initial displacement. It's called S naught. Okay. Similarly, the third equation of motion, if you put T equal to 0, the displacement S, if I put as 50, then V will be different from U. So here also I should make a modification as S minus S naught. So this is a better way of writing the equations of motion, where S naught is the initial displacement at time T equal to 0. So when S naught is 0, you get the original equations of motion. So the information in these equations can be represented in terms of graphs. Consider the first equation, V equal to U plus AT. T is the time. It's an independent variable. The initial velocity will be given usually, and A acceleration is also usually known. Because the force that's creating the motion should be known, and acceleration is same as force, because according to Newton's second law of motion, force is mass into acceleration. So force is same as acceleration except for this scaling factor mass. So since force acting on the body which is producing motion is known, acceleration is known. So here the variables are V and T. T is the independent variable. So the information, the first equation I can get using this graph. We plot V versus T. It will look like this. It will be a straight line because V is on the y-axis, T is on the x-axis. So this equation is of the form y equal to some constant C plus A is another constant M, and then T is on the x-axis. So it's of this form y equal to mx plus c, which is the equation of a straight line. the power of x and y is 1, so it's a straight line. So here, in this particular straight line, at time t equal to 0, this value is initial velocity u. And the slope of this line, which is n, which is a here, it's positive. A line with positive slope will look like this, with negative slope will look like this, it will go down. Okay, so here, another case of this graph will be like this, it could be like this. So here, this graph corresponds to u less than 0 and a greater than 0 because slope is positive, but the initial velocity, it's negative. This is the origin, u equal to 0, v equal to 0. So it's above is positive, below is negative. So for this graph or the motion representing this graph, the initial velocity is negative. Similarly, you can have two more cases. One is this one. So for this motion, u, the initial velocity is positive, but the acceleration is negative. Acceleration of the slope, it's going down, so it's negative slope. So the final possibility will be like this. This line, for this u is negative, initial velocity is negative, and acceleration is also negative. So this graph, there are only 4 possible cases. It's basically u and, so both can be positive, or u can be negative, a positive, and then a negative, u positive, a negative and u negative. 4 possible cases. So the first one is this one, and then u negative. So this is the second case. Third case, u is positive and a is negative. This is the third case, and this is the fourth case. Both are negative. U is negative and downward slope. So this is the fourth case. So uniform acceleration, uniform constant acceleration. So this is the graph corresponding to the first equation of motion. Similarly, we can draw a graph corresponding to the second equation of motion. AC equal to ut plus half at squared. So in this second equation, again the initial velocity will be known usually, and the force that's creating the motion is known. So that means acceleration is known. So here we have to plot s versus t. So s on the y-axis and t is the independent variable on the x-axis. So this is a parabolic equation because equation of parabola is y equal to ax squared plus bx plus c. X variable is time, so x square is there, x is there, and y is nothing but s. Actually, constant term is s naught. Okay, so, and if this a is positive means the parabola will look like this. X versus y. This parabola will look like this if a is positive. This is basic of parabola. So if a is negative, then the parabola will look like this. This also allowed, it can also go like this, or it can also go like this. For all these three, a is negative. Similarly, this a positive, it can also be like this, or it can be like this. So here in this case, if we assume a is positive, then the graph will look like at t equal to 0, this one is s naught. So it can look like this. Right? This case is a is positive. This is initial displacement s naught. For a positive, that's another possibility is this initial displacement can be negative, so it can be like this. So this also s naught negative and a positive. So when E is negative, it will be an inverted parabola like this. So look like this. So this is S naught positive, but E is negative. This inverted parabola can also look like this. Start from negative S naught and then go down. So this E is negative. So here also there are 4 cases depending on the sign of S naught and E. So first is both are positive. Second is this positive, this negative. First one is this one. Second one, A is positive but S naught is negative. Third case, A is negative, S naught is positive. And then fourth case, both are negative. Invert parabola and S naught is also negative. So this is the graph of this second equation will look. So the third one, third equation of motion. The initial velocity U and the acceleration, if they are known, then the variables are V and S. As time progresses, the displacement will change, correspondingly the V will also change. So here we can plot V on the vertical axis or Y axis and S on the horizontal axis, the displacement S. Like y equal to ax square plus bx plus c is a parabola. Similarly, we have x equal to ay square plus by plus c. This parabola will look like this. This axis is y axis, so it look like this, like c. Okay, this is for a greater than 0. So if a is negative, means it look like inverted reflected c. Like y equal to ax square plus bx plus c. The parabola will look like this u or inverted u. This parabola the x-axis. So here we are interchanging x and y. Okay, so the parabola will be about the y-axis. So it look like C or inverted reflected C. Look like C if A is positive. If A is negative, look like a reflected C. So with that basic idea, you can figure out this graph of this one. So this is the y-axis. So this is the form y square equal to some constant plus some constant into the x value. Okay, so this parabola and this thing is A if it is positive, we'll look at this. And one more thing is at initial time, S is S naught. And then B will keep on increasing as S increases. So this is one possibility where A is positive. A is positive and S naught is positive. So if S naught is negative, means look like this. This is the second case, S naught, and again A is positive. Here S naught is less than 0. Here S naught is positive. Similarly, if A is negative, we'll have reflected C, this one. So it can look like this. S naught is positive, but acceleration is negative. I can also have like this. So for this fourth case, S naught is negative, and this acceleration is negative. So here also you have 4 cases. So with this understanding, we can solve the JEE Main question. You can read it. A tennis ball is released from a height h and after freely falling on a wooden floor, it rebounds and reaches height h by 2. The velocity versus height of the ball during its motion may be represented graphically by 4 options are given. Graph are drawn schematically and not to scale. You can pause and run this question. So here a ball, tennis ball, is thrown from a height h. on a wooden floor. This is a wooden floor. So from a height h, it is dropped. So it'll keep coming down. It'll hit the floor and then rebound. And it rebounds to a height of h by 2. So it comes up to this point. So here the velocity is 0. So this height is h by 2. Okay. So for this motion, you have to plot. Obviously, as the ball keeps on moving, the height is changing. So you have to plot velocity versus height. So basically, you have to plot this v versus displacement using this third equation of motion. V square equal to u square plus 2as. Instead of s, it's better to put s minus s naught if there is some initial displacement. For this particular question, I'll choose origin of coordinate system here at the wooden floor, and this is the positive direction. So according to this choice of the origin, initially the displacement is h, so this s naught is required. So for the the downward motion, first is falling down. So for the downward motion, if I write this v square equal to u square, u is 0 because it's released from height h. U is 0, and then acceleration is downwards minus g, that's due to the Earth's gravity, and s minus the initial height is h. So this is the equation for the downward motion, the first part of the motion. The second part, the rebounding part, where the thing is going up. I write the same equation, v square equal to, there is some velocity here, u2. The second part of the motion, u2. So let me call that u2. u2 square plus 2, acceleration is minus g. Yes, the initial displacement, the displacement at time t equal to 0 is 0, which is 0. So s naught is 0 for the second part. Here, for the second part, the time starts after it hits the floor. Okay, so the first part of the motion, so this is again, v is on the y-axis. So this is like y square, the upward motion is of the form y square equal to some negative constant into x. Okay, so this parabola about the y-axis and it's negative, so it will be reflected c. So this plot will look like reflected c. So that is reflected c will look like this one. So the second part of the motion where it's going down is of the form y square equal to some constant plus some negative number into x. Again, it's also reflected c. And it's a parabola. So we can rule out this option, it's a straight line. This is not a parabola. So this is more appropriate, this is like a parabola. So here, the initial time t0. After that t1, suppose I call this initial time as t0 when it's getting released. And this time, say somewhere here, t1, and when it hits the floor, let the time be t2, and let the time here be t3, and t4 is the maximum. So this time is t0, t1, t2 here, this also t2, and t3, and then t4. So option C is the correct answer. So this is what I explained here. The tennis ball is released from a height h, initial velocity 0, so it keeps falling down. It hits the wooden floor and rebounds back to height h by 2. Okay, so the first part of the motion is going down motion. Further, the initial velocity u1 is 0, the velocity here, and v1, the velocity at this point, it's the maximum velocity because it keeps on accelerating, reaches the maximum velocity at this point. So v1 is vmax. So for the second part of the motion, u2, it's reaching a height of h by 2, so there is some loss of energy here. So this rebound velocity will be less than Vmax, and the velocity at this topmost point V2 is 0 because the maximum height point will keep on going up until it becomes 0 velocity. Okay, so using the third equation of motion, V square will be U square plus 2as. Instead of s, we have s minus s naught because there is some initial displacement with this choice of origin. So this displacement axis, this is the origin. So according to this choice of the origin, initial displacement is h. So the first part of the motion is downward motion. For that, v square equal to initial velocity is 0, u square is 0, and then 2, acceleration is minus g because earth is pulling it down. And s, and initial displacement s is, s naught is h. Upward direction is positive, so s naught is plus h. Upward is positive and origin is flow. So the initial displacement s naught is h, but the initial velocity u is 0 because it's reached from the height h. So this is y square because I'm plotting v on the y-axis. This is x variable. So it's of the form y square equal to some negative number into x. So it's a reflected C parabola. And upwards motion, v square will be u square plus 2as. U is the sum as initial velocity u2 square. And then 2a, s minus s naught. S naught is 0 because at the initial time, the displacement is 0. So this again, y square equal to some constant plus negative number into x. So it's again the reflected C parabola. So correct option is option C. So the third equation of motion v versus s is a parabola about the v axis. Second equation of motion s versus t is a parabola about the t axis.